So in this last step of the TensorFlow Cats&Dogs as a model implementation and training, we're going to deal with the custom training loop. So let me just copy the code and explain what goes on. So essentially what we know is during training there's the forward pass and the backward pass. So in the forward pass, the dataset is passed through the model, and then after that the cost function, or rather in this case the loss function, in PyTorch is usually defined by a variable known as criterion. The criterion computes the difference between the predicted values by the model and the truth values, which ought to be the output. And using this cost function, we get to propagate the loss back to the weights of the model, and then using chain rule and then using the optimization function, we get to compute how much gradient has been accrued from the loss of the weight loss, which then from there we get to apply the gradients and hence tend to update the weights in such a manner so as to reduce the cost function. Yeah, so essentially the cost function always guides the optimization function on how to reduce or not to adjust the weights. And the optimization functions, so there's the gradient descent, stochastic gradient descent, we have others, we have Adam, we have the so many optimization functions. So here we have the stochastic gradient descent, which essentially is a random way of it's actually modified gradient descent, which uses randomization to always overcome the problem of local minima. So then we have the loss function, which is the categorical cruise entropy. So since this is a classification problem, we are going to use categorical cruise entropy, but essentially we can, for regression problems, this is for models which predict continuous value outputs, we can use the root mean squared error or other loss functions. Then we have a metric. This helps us to keep track of the performance of the model, but essentially it has no effect on the training. So the optimization and the loss function is what is usually used in the forward pass and the backward pass, essentially in the backward pass to be precise. Then this one just helps us to keep track of everything that goes on. Then yes, so we start the epoch, we enumerate the dataset, we get the images and the batches, and then we pass the images through the model, we get the raw probabilities known as the logits. Then we compute the difference between the truth values and the raw probabilities as predicted by the model, and then we get to keep track of that loss. Essentially this one helps us to propagate the loss from the loss value to the trainable weights, and then using the optimizer we get to update the weights as per the gradients determined by the loss value. And then after we update the weights, we get to calculate the performance of the model at that time. And then after that, now we state out the loss and accuracy values that we have achieved. Then for the validation, the same thing goes on. Yeah, so now what you have to do is just to activate the GPU, change runtime type. This one you change it to GPU, and then you train it. So yeah, you train it, and then it will take a while, and then after that we would now in the next part when I'll be talking about deployment stages of the TensorFlow model to cloud, to mobile platform where we will be building a mobile app, or to the web app where we'll be using the TensorFlow JS, and also we'll be using a Firebase storage for hosting the model in the cloud. We'll be talking about, we'll go into details on how we create the inference of the inference, I'll call it the inference architecture of the model, so that we can better get to deploy the model in a nice format. So yeah, this is the end of the training video for TensorFlow on Cats and Dogs. So we'll see you next time.